solve this section 5.3 problem where we're using part one of the fundamental theorem of calculus to find the derivative of the function. Okay, so let's write down first what the fundamental theorem of calculus is. So part one, the fundamental theorem of calculus part one says that the derivative of a function defined as a to x f of t dt, that derivative is equal to f of x. So that's what we're going to use here. So we're trying to find the derivative. What we're not going to do is evaluate the integral and then take the derivative of that answer. So for this guy right here, it says here, trying to find the derivative. So we have g prime of x, and that will be the derivative. Now what I'm doing is sort of making this seem like a longer problem than it is. You don't really have to write that step there where I just put d dx in front of this. Now, what the fundamental theorem of calculus is saying is that these guys cancel each other out. For this particular function, which I would agree is sort of a weird looking function, this function that has the integral from a to x, the input variable is x. That's our independent variable x. What's it doing up there? Well, that's the way it's written. Okay. So those two cancel out and we get the square root of, now at this point, I'm going to copy down this function. If I copy down t plus t cubed, that seems pretty good, except I'm using x as the variable. I could do one of two things. I could change that x to a t, still correct. But the way that we usually do this, and the way I'm going to ask you to do this is have both sides have an x. So I'm going to put x over here. And by the way, someone will say, well, what happened to the dt? That gets canceled out too, because the whole d dx of all this, it kills the whole integral. And that includes, that's the 0 to x and the dt. Okay, so that's our answer. And it doesn't, in a way, it looks a little unnatural, but we got to go over that. We're going to do that. Over here, for whatever reason, copying the problem out of the book, they're using this s, which looks a lot like a 5. But anyway, g prime of s is the derivative. And what happens with the derivative? The derivative kills the integral. And then, right, so I'm showing fewer steps. In fact, I'm just about to only show the answer, so maybe that's not so good. So I'll write d ds, integral from 5 to s. Now, it doesn't matter what's on the bottom, 0, 1, 5, that doesn't come into play. We can talk about that, explain why that's the case. But so again, these things, they cancel out. Cancel, cancel, cancel. So cancel culture, but no, that's not what this is. Okay, cancel out. And I get g prime of s is equal to s minus s squared to the 8th power. Okay, so we did 2 problems there. Let's do one more problem, finish this page. So we're doing 7, 9, and 11. All right, this problem here, okay, what's going on is I have this function, but look, the number constant 0 is on the top of that bound, and then the variable x is on the bottom. So the key is what we're going to do is we're going to flip this. I'm not taking the derivative yet. I'm going to flip this, flip the bounds, flip the sign. I know I need a rhyming thing there, but when we flip the sign, flip the bounds of integration, we change the sign. Here's positive, becomes negative. That's a note, the hint that's given by the author. To me, it's sort of too much of a hint. Should be able to figure that out. Okay, take the derivative. So it's going to be d dx of this negative. Okay, put the negative there. Okay, and what happens? Once again, cancel, cancel, cancel. And so I get negative square root. Don't keep t. We're going to put in the variable that's up here, which is x. Put that variable x in where t goes. So I put 1 plus secant x. So by the way, I feel like in the last one, I didn't really emphasize that enough. On the last problem, number 9, and we didn't have x as our variable, s was our variable, and we put that guy in for where t goes. That's what we put in. We put s in. So here on the top is variables x, and we put x in for t, and the other one s goes in for t. So all right, that is that's that. 7, 9, and 11. Fundamental theorem of calculus, part 1.